Those ships are 100 kilometers from the nearest water. They weren't always. In 1960, this was the fourth largest lake on Earth, 68,000 square kilometers of open water, a fishing industry that fed 3 million people, a functioning ecosystem that had been stable for centuries. Today, most of that water is gone, and we are not going to pretend otherwise. This video is about one part of that former sea, the North Aral in Kazakhstan, and the exact point where one intervention reversed a death spiral declared permanent. It is not a story about saving the Aral Sea. It is about the difference between a system that still has a leverage point and one that does not, and why getting that distinction right is the most important skill in environmental engineering. The Aral Sea was fed by two rivers, the Syr Darya from the northeast and the Amu Darya from the south. Together, they delivered about 56 billion cubic meters of fresh water per year, enough to balance natural evaporation for thousands of years. In the 1950s, Soviet planners turned Central Asia into the USSR's cotton machine. Cotton can require roughly 10,000 liters per kilogram of fiber, and Central Asia is a desert. So they built 30,000 kilometers of canals, 45 dams, 80 reservoirs. Both rivers were tapped. The canals were mostly earthen trenches. No concrete lining, no covers. Between 25 and 75% of the water never reached a crop. It seeped into the sand or evaporated in the heat. By 1987, annual inflow to the Aral Sea had dropped from 56 billion cubic meters to near zero in dry years. The evaporation deficit was now compounding every single year. As the level fell, the lake got shallower. Shallow water heats faster, evaporates faster, shrinks further, gets shallower still. A loop feeding on itself, accelerating every year. By the late 1990s, the southern basin had reached 100 grams of salt per liter, 10 times its original concentration, twice as salty as the ocean. In 1987, the water dropped below the Berg Strait, the narrow channel linking the two halves. The lake split. From that point on, the north and the south evolved on entirely different trajectories. The open channel became a biogeographic barrier. The north retained traces of life. The south became a chemical solution for most macroscopic organisms. The North and South Aral were not the same problem. The south depended on the Amu Darya, a river largely consumed by Uzbek and Turkmen irrigation before it reached the sea. That was a political and agricultural problem no dam inside the lake could fix. The Syr Darya was diminished, but still delivering water, between 2 and 12 billion cubic meters depending on snowmelt. The problem was hydraulic. Every cubic meter entering the northern basin drained south through the Berg Strait, spread across near-flat desert terrain, and evaporated within weeks. The North Aral was a bathtub with the drain open. The geometry was the key. The north was deeper relative to its surface area. Concentrate water in a deep, confined bowl, and evaporation per cubic meter drops dramatically. The physics was already there. What was missing was the stopper. In 1992, Tanirbergen Darmanov, the mayor of Aralsk, and a team of local engineers proposed closing the Berg Strait, not with a dam. With dump trucks, sandbags, and earth-moving equipment, a wall of dirt across 13 kilometers of open water. Scientists called it naive. Officials in Almaty called it a waste. The international community had largely written the Aral Basin off as an irreversible sacrifice zone. They built it anyway. The water behind the dike began to rise. Salinity started dropping. Fish appeared in water that had been biologically dead. For several years it looked like it would hold. Then, in the spring of 1999, the Syr Darya surged with exceptional snowmelt. The sand dike was not designed for that volume. The structure failed. 2 workers died in the collapse. Years of recovery drained back into the desert within weeks. The failure had proven something more valuable than success. The water had risen, the chemistry had changed, the fish had come back. The physical logic of the intervention was correct. What failed was not the concept, it was the materials. That proof of concept, paid for with local engineering and 2 lives, finally brought serious institutional money to the table. In 2001, the World Bank and the Kazakh government committed $86 million to the Syr Darya Control and North Aral Sea project. Its centerpiece was the Kokaral Dam, a permanent concrete and earth-fill barrier across the Berg Strait, completed in August 2005. The principle was simple: trap the Syr Darya's inflow inside the northern basin. As the level rises, the same water occupies less exposed surface, less sun and wind, less evaporation. The water rises instead of disappearing. The dam learned directly from the 1999 disaster. The Kokaral structure includes a 9-gate spillway rated at 600 cubic meters per second. The World Bank funding also covered canal modernization along the Syr Darya. For decades, unlined irrigation canals had been losing 30 to 50% of their flow to seepage. Concrete lining and improved infrastructure returned hundreds of millions of cubic meters per year to the river's downstream flow. Those 167 modernization projects are part of the Aral Sea Basin Program, coordinated by the 5 basin states since 1993, with funding from the World Bank, the Asian Development Bank, and Kazakhstan's national budget. The dam was the headline. The plumbing behind it was the quiet multiplier. Scientists predicted it would take 3 to 5 years for the North Aral to reach its target water level of 42 meters above sea level. It took 7 months. By early 2006, the water had risen 3.3 meters. The shoreline, which had retreated 100 kilometers from Aralsk, came back 25 kilometers in a single year. Every projection had been wrong, in the right direction. The salinity drop explains the biological rebound. Below 10 grams per liter, native Aral fish can spawn and their eggs survive. Above that threshold, reproduction fails regardless of adult fish population. The fall from 30 grams to 8 to 10 crossed that line decisively. 22 native fish species returned without stocking, migrating from the Syr Darya Delta. Pike perch became the dominant commercial catch. The reed beds trap moisture and help block the toxic dust storms that had been shredding the region for decades. Dust storm frequency near the northern shore has decreased. In Tastebek, occupied houses tripled. Families who left for Almaty are returning. Reverse rural migration in Central Asia is almost unheard of. Pike perch from the North Aral is now exported to Russia, the European Union, and China, and the Aral Fresh Fish Processing Plant in Aralsk holds international export certification. But if the lakebed spent decades collecting pesticide runoff, heavy metals and agricultural chemicals, and now that same contaminated sediment is sitting under a recovering lake, how do we know the fish are actually safe to eat? It is a legitimate question. It deserves a direct answer. The primary mechanism is dilution and sediment chemistry. Much of the toxic load, DDT metabolites, lead, cadmium, chlorine-based pesticides, is bound into the salt crust and sediment. It does not readily dissolve when fresh water returns. Research linked to the International Fund for Saving the Aral Sea has found heavy metals in North Aral water within accepted freshwater limits, though sometimes near upper bounds. Commercial pike perch samples have passed Kazakh and Russian food safety standards. But the dam did something else. It did not just save the north. It drew a line through the disaster. On one side, water was rising. On the other, the South Aral was still disappearing. The southern basin is far larger, far shallower, and fed by a river, the Amu Darya, almost entirely consumed before reaching the former shoreline. The Amu Darya begins in the Pamir and Hindu Kush mountains, then passes through competing water users. Uzbekistan alone diverts an estimated 60% of its flow into irrigation. In most years, by the time the river reaches the former southern shore, almost nothing is left. In 2014, the eastern lobe of the South Aral evaporated completely. In Moynak, the former port city, the sea did not come closer. It kept moving away. Uzbekistan is now drilling for natural gas in parts of the former seabed, a sign that economically the water is not expected to return. There are proposals for the south: retention dikes, irrigation modernization, and more efficient water delivery across the Amu Darya basin. But none of them change the central problem. The South Aral has too little water coming in and too much surface exposed to evaporation. Without a major return of the Amu Darya, engineering can slow the loss in places, but it cannot recreate a sea. That is why the north and the south tell two different stories. In the north, the Syr Darya was still flowing. The basin was deep enough, the geometry still worked. One wall, placed in the right location, could change the system. In the south, the input was gone. The geometry was against it. And when the input is gone, engineering cannot substitute for hydrology. But the north is not finished. Kazakhstan now wants to raise the Kokaral Dam by 2 meters, from a 42 to a 44-meter target water level. If inflows hold, the sea's volume could rise again, and the shoreline could move closer to the old port of Aralsk. Canal upgrades, flow monitoring, and irrigation improvements are meant to send more water downstream. The goal is simple: keep more Syr Darya water in the system and give the North Aral a larger future. Those ships are still there. At Moynak, on the Uzbek side, the fleet sits on the Aralkum Desert, in water that is not coming back, a monument to a system that crossed the point of no return. The North Aral shows something different. One dam, 13 kilometers, $86 million. The water rose, the fish came back, the town is filling up again. Gravity, geometry, one wall in the right place. Every system broken by human decisions contains one question worth asking: is there still a leverage point? Sometimes the answer is no. The South Aral answered no, but sometimes the answer is yes. If that question interests you, subscribe.